Hello student. Now in this video we will see the practice set 3.4 and in this video we will see the topics, that is a perpendicular bisector theorem and its converse, angle bisector theorem and its converse, and the inequalities of the triangle, that is a side opposite to greater angle is a greater and the side opposite to smaller angle is a smaller. Now let us start the new topics, that is the perpendicular bisector theorem, angle bisector theorem, and inequalities of the triangle, and the practice set 3.4. Now the first topic is perpendicular bisector theorem. Every point on the perpendicular bisector of a segment is equidistant from the end points of the segment. Means what? That is, AB is the line segment and line L is a perpendicular bisector of the segment AB. If you take any point on this line, that point is equidistant from these two end points. Suppose that P is a point on this perpendicular bisector, then AP is equals to PP. Now let us prove this. That is, a line L is a perpendicular bisector of segment AB at point M. Point P is any point on L which is on the perpendicular bisector. Now we want to prove that PA is equals to PB. This P is equidistance from A and B. Construction: draw segment AP and BP. Join this AP and the BP. Now in triangle PMA and the triangle PMB, in these two triangles, that is, segment PM is a congruent to segment PM, angle PMA is a congruent to angle PMB, that is each right angle, each 90. AM is a congruent to MB, which is the given. Therefore, these two triangles, that is, a triangle PMA is a congruent to triangle PMB by the test SAS test. Therefore, PA is a congruent to PB. PA is a congruent to PB, that is the corresponding sides of congruent triangles, and hence every point on the perpendicular bisector of a segment is equidistant from endpoints of the segment. Second, any point equidistant from the endpoints of a segment lies on the perpendicular bisector of the segment. Now in this case, that is, P is any point which is the equidistance. Now in this case, that is, AP is equals to PP, which, and next is AM is equals to MB. That's where given. Therefore, to prove that is, the point P is on the perpendicular bisector of segment AB. That is, for that construction, take M, the midpoint of segment AB, draw PM. Now we will consider the two triangles PMA and the PAM and the PBM. In these two triangles, PA is a congruent to PB, it's a given, and segment AM is a congruent to MB. M is the midpoint of segment AB, and the next is a PM is a congruent to PM, which is the common side, and therefore the triangle PAM is a congruent to triangle PBM. So by the SSS test. Now see this here, that is, the angle PMA is a congruent to angle PMB. That is the corresponding angles of congruent angles. These two angles are equal. But these two angles are linear angles. Their sum is equals to 180. That is, measure of angle PMA plus measure of angle PMB is equals to 180. Therefore, measure of angle PMA plus PMA plus PMA is equals to 180. As these two angles are equal, out of these two angles, या दोघांपैकी आपण एक अँगल ट्रीट करणार आहोत. मग तो किती घेतला तर PMA घेतला. Therefore, PMA plus PMA, that is the 2 times angle PMA, that is equals to 180. Therefore, measure of angle PMA is equals to 90 degree. Therefore, segment PM is a perpendicular to segment AB. That is, segment PM is perpendicular to segment AB. Therefore, the line PM is a perpendicular bisector of segment AB. So the point P is on the perpendicular bisector of segment AB. That's what we want to prove. Now the next is angle bisector theorem. Every point on the bisector of an angle is equidistant from the sides of the angles. That is, we want to prove that in triangle PQR, QS is angle bisector, and every point on this QS is equidistant from the ray QP and the ray QR. That is, AB is equals to AC. This we want to prove. Ray QS is the bisector of angle PQR. Point A is any point on a ray QS. Segment AB is a perpendicular to segment QP, and the segment AC is a perpendicular to segment QR. We want to prove that segment AB is a congruent to segment AC. We consider the two triangles, that is the triangle ABQ, and the triangle ACQ. In these two triangles, segment QA is a congruent to segment QA, which is the common sides. Next, measure of angle ABQ is a congruent to measure of angle ACQ. ABQ is congruent to ACQ, which measure is 90. And next is bisector. Therefore, measure of angle AQB is a congruent to measure of angle AQC. That is, the ray QA is a bisector of angle PQR, and that's why the triangle ABQ is a congruent to triangle AQC by the test SAA test of the congruence. That is, we are considering the two angles and one side. That is the angle adjacent to side and angle opposite to that side. Therefore, the segment AB is a congruent to segment AC, CSCT, and this is that is this point. Point A is an equidistance from these two sides. Now the next, it's a converse part. Any point equidistance from the sides of an angle is on the bisector of the angle. Let A be the point in the interior of the angle PQR. Segment AC is a perpendicular to QR, and the segment AB is a perpendicular to PQ. AB is equals to PQ, and then we want to prove that this point A is nothing but on the angle bisector, which is a QA or QD. To prove that the QA is the bisector of the angle PQR, that is, we want to prove that is the measure of angle BQA is equals to measure of angle CQA. This we want to prove. Now we'll consider the two triangles, that is the ABQ. Next is the ACQ. In these two triangles, measure of this angle ABQ is equals to measure of angle ACQ is equals to 90. That is given. Hypotenuse, which is the common side. That's again hypotenuse AP is congruent to hypotenuse AQ, and the AB side AB is congruent to side AC, which is given. Therefore, the triangle ABQ is congruent to triangle ACQ, and by the test side hypotenuse test. And that's why measure of angle BQA is a congruent to measure of angle CQA, corresponding angles of congruent angles, and hence that is the array QA is the bisector of angle PQR. Now next, that is the properties of the inequalities of sides and the angles of the triangles. If the two sides of triangles are unequal, then the angle opposite to the greater side is greater than the angle opposite to smaller side. Now consider the triangle XYZ. XYZ. That is, side XZ is greater than side XY. XZ is greater than XY. Then what we want to prove that is the angle opposite to XZ, which is opposite to angle opposite to XZ, that is angle Y. That is the angle XYZ is greater than angle XZY. This we want to prove. Take the point P on XZ such that XY is equals to xp. xy is equals to xp. Draw the segment yp. Now consider the triangle xyp. What's happening? That is, these two sides are congruent. And the next, measure of angle xyp is equals to measure of angle xpy. xyp is equals to xpy. That is an isosceles triangle. Now the angle xpy is an exterior angle of the triangle ypz. ypz. xpy, this is the exterior angle of this triangle, which is the triangle ypz. And its measure is a greater than. Now see this figure. That is, measure of angle 1 is a greater than measure of angle 3. एकाचं माप 3 पेक्षा कसं जास्त आहे. पण हा पण एक आहे आणि हा पण एक आहे. म्हणजेच काय, या इथल्या एकाचं माप या 3 पेक्षा जास्त आहे. परंतु या एकामध्ये मी पुन्हा हा 2 ऍड केला. दॅट इज इफ आय ऍड, दॅट इज मेजर ऑफ अँगल xyp plus measure of angle pyz. It's a clear that this sum is greater than measure of angle xzy, and that's why, that is, here it is written. What is that? That is a measure of angle xyp is greater than measure of angle pzy. If I add the measure of angle pyz, then till it is greater than this, that is a measure of angle pyz. That is, if a is greater than b and c is greater than 0. If I add a, then what will happen? A plus c is greater than b. And that's why measure of angle xyz is greater than measure of angle pzy, and that is a measure of angle, that is a measure of angle xyz is greater than xzy. xyz is greater than xzy. That is, if xz is greater, then angle opposite to xz, which is that xyz, is greater, and this is a small, therefore its angle is a small. This is the property. Now the next is, if the two angles of a triangles are unequal, then the side opposite to greater angle is greater than the side opposite to smaller angle. This proof can be proved by indirect proof. Complete the following proof by fill in the blanks. That is, what's happening in triangle ABC? In triangle ABC, measure of angle B is greater than measure of angle C. Then which side is opposite to angle B? AC is opposite to B. And what about the C, angle C, AB? Therefore AC is greater than AB. The angle मोठा असेल तर त्याच्या साइड्स, त्याच्या अपोजिटची साइड देखील कशी असणार आहे, तर मोठी असणार आहे. There are 3 possibilities regarding the length of AB and the length of AC of the triangle ABC. First is AC is less than AB. Next is AC is equals to AB and AC is greater than AB. म्हणजे काय की AC हा AB पेक्षा लहान असणार, ते दोन्ही इक्वल असतील, and AC is greater than AB. First possibility we'll consider. If we assume that की AC हा AB पेक्षा लहान आहे. If AC is less than AB, AC लहान आहे, मग AC समोरचा अँगल काय की अँगल B येणार, आणि AB समोरचा अँगल काय तर अँगल C. That we will get that if the two sides of the triangles are equal, then the angle opposite to greater side is greater. Then what about the AC? That is in this case, that is the angle opposite to AB. Angle opposite to AB is angle C, and the angle opposite to AC is angle opposite to AC is B, and angle opposite to AB is C. That is, C is greater than B, but we have given that the B is greater than C. Yes, we have given that B is greater than C. Therefore, this contradicts. Therefore, our assumption, that is first possibility, is wrong. What about the second? If AC is equals to AB, if AC is equals to AB, then what will happen? But these two angles will be equal. That is AC is equals to AB. That is, measure of angle B is equals to measure of angle C. But again, we have given that the measure of angle B is greater than measure of angle C. Now the two possibilities are wrong. Therefore, it's clear that the third possibility is correct. Therefore, AC is greater than AB. Now the next. The sum of any two sides of a triangle is greater than the third sides. तुम्ही देखील करून बघू शकता की कुठलाही ट्रायंगल घ्या आणि त्या ट्रायंगलच्या दोन साइडची ऍडिशन करा. ती ऍडिशन उरलेल्या थर्ड साइड पेक्षा जास्त असते. दॅट इज we have given the triangle ABC. ABC is a triangle, and that is the first case is AB plus AC is a greater than BC. Second is AB plus BC is greater than AC, and AC plus BC is greater than AB. Now we'll through the first part, that is a construction. Take a point D on ray AB such that AD is equals to AC. Take the point D on AB extended such that AD is equals to AC. Therefore, you will get that is the triangle ACD. In the triangle ACD, what's happening? AC is equals to AD. This is our construction. AC is equals to AD. Now, next, that is the measure of angle ACD is equals to measure of angle ADC. That's the angle opposite to congruent sides. No problem. It's isosceles triangle. Now, next, measure of angle ACD. Measure of angle ACD plus measure of angle ACB is a greater than measure of angle ADC. Measure of angle ADC. It's a clear that. If I add another measure of angle, which is that ACB. Now these two are equal. जर मी याच्यात अजून एक अँगल ऍड केला तर निश्चितच या दोघांची टोटल काय होणार तर ADC पेक्षा मोठी येणार. Therefore, what about the measure of angle ACD plus ACB? ACD plus ACB is nothing but the measure of angle BCD or DCB. Therefore, it's a BCD. BCD. That is measure of angle BCD is greater than measure of angle ADC. Measure of angle ADC. आता आपण सगळ्यात मोठा ट्रायंगल कन्सिडर करणार, which is that BCD. या BCD मध्ये काय? That is the measure of angle BCD is a greater than measure of angle BDC. मग BCD समोरची साइड कोणती आहे? तर BCD समोरची साइड BD आहे. मग BD असेल, परंतु आपण आपला ओरिजिनल ट्रायंगल काय आहे? तर our original triangle is triangle ABC. There now in this case BD is a greater than BC. Instead of that is the BD can be written as AB plus AD. Therefore, AD is replaced by AC because AD is not the side of our original triangle. Therefore, we replace this AD by AC and hence AB plus AC is greater than BC. Now see this here. That is BD is greater than this BD is greater than BC. That is the measure of this 1 plus 2 angle is greater than measure of this angle. Now this BD can be written as BA plus AD. That is which is greater than, but replace AD by AC and BA plus AC. BA plus AC is greater than BC, and similarly we can prove the other inequality, that is AB plus BC is greater than AC and BC plus AC is greater than AB. Now we'll start the practice set 3.4. In figure, the point A is on the angle bisector of angle X, Y, Z. AX is equals to 2. Then find AZ. AX is equals to 2. Then find AZ. Now as the point is on the angle bisector, therefore AX is equals to AZ. AX is equals to 2 centimeter. Therefore AZ is equals to also 2 centimeter. That is every point on the angle bisector is equidistant from the two sides of the angles. Therefore AZ is equals to 2 centimeter. Next in figure, that is measure of angle RST. RST is equals to 56. Segment PT is a perpendicular to ray ST, and segment PR is a perpendicular to segment SR, and segment PR is a congruent to segment PT. Therefore, find the measure of angle RST. We want to find out the measure of angle. Now this is the bisector. Therefore, measure of this angle is equals to 1/2, whatever that the measure of angle RST. That is. Now in this case, segment PT is a perpendicular to segment ST, which is given. Segment PR is a perpendicular to segment SR. Here it is given. Segment PR is a congruent to segment PT, and therefore that is a PR is equals to PT. That is the point P is equidistance from the sides of angle TSR. That is the point P lies on the angle bisector of TSR, and therefore at the measure of angle RST is equals to 56. Therefore the measure of angle RSP is equals to 1 upon 2 measure of angle RST. But what is RST? RST is 56. 1 upon 2 into 56, which is equals to 28 degree. Therefore, the measure of angle RSP is equals to 28 degree. Now, the next question. In triangle PQR, PQ is equals to 10 centimeter, QR is equals to 12 centimeter, PR is equals to 8 centimeter. Find the greatest side and the smallest side of the triangle. Find the greatest and the smallest angle of the triangle. Now, we have given the sides. PQ is equals to 10 centimeter, QR is equals to 12, and PR is equals to 8. Now see the sides. That is the biggest side, greater side is the QR, then PQ, and then PR. Then the angle opposite to QR is a QPR, angle opposite to PQR, angle PRQ, and the angle opposite to PR is angle PQR. Angle opposite to greater side is a greater, and therefore the measure of angle QPR is a greater than, is a greater angle, and the measure of angle PQR is a smaller angle. Again, I will repeat. Measure of angle QPR is a greater, and measure of angle PQR is a smaller. Now the next question. In triangle FN, measure of angle F is 80, measure of angle is 40 degree. Find out the greatest and the smallest side of the triangle. State the reason. That is measure of angle F plus measure of angle A plus measure of angle N is equals to 180. That is 80 plus 40 plus measure of angle N is equals to 180. That's the sum of the angles of the triangles. That is F is equals to 80, A is equals to 40. Therefore, the measure of angle N is equals to 180 minus 120, and that's equals to measure of angle N is equals to 60 degree. Now the angles of the triangles are in this sequence. What is the greater angle? The greater angle is 80, next is 40, and last N is 80, 60, and 40. That is F and A. The side opposite to angle F is AN, side opposite to angle N is FA, and the side opposite to angle A is FN. That is side opposite to the greater angle is a greater. Therefore, which is the greater side? That is AN is the greater side of the triangle, and the FN is the smaller side of the triangle. ज्या अँगल समोरची अँगल जर मोठा असेल तर त्याच्या समोरची साइड देखील मोठी असतील, छोटा असेल तर लहान असणार आहे. In this way. Now the next, prove that an equilateral triangle is equiangular. Now that is a triangle ABC is equilateral. Now we want to prove that the triangle ABC is equiangular. That is, in triangle ABC, AB is congruent to AC because the sides of equilateral triangle. As the sides are congruent, therefore measure of angle ABC is equals to measure of angle ACB. The isosceles triangle theorem. In triangle again ABC, AC is congruent to BC. Again that is the sides of equilateral triangle. Therefore measure of angle ABC is congruent to measure of angle BAC. Isosceles triangle theorem. Therefore from 1 and 2 all these angles are equal. That is the measure of angle ABC is congruent to measure of angle ACB is congruent to measure of angle ABC, and therefore the triangle ABC is equiangular. Now the next question, that is the question number 6. Prove that if the bisector of angle BAC of triangle ABC is a perpendicular to side BC, then triangle ABC is an isosceles. It's a bisector of the angle BAC. Now consider the triangle ABC and the bisector of BAC. Which is the bisector? AD is a bisector. It's a perpendicular. Then we want to prove that this triangle ABC is isosceles. Now we'll consider the two triangles. Which are the two triangles? Triangles ADB and the triangle ADC. In these two triangles, angle BAT is a congruent to angle CAD. This is given. What about the next AD, which is the common side? Again, the measure of angle ADB is a congruent to measure of angle ADC. Therefore, by the test, which is the test? ASA test. These two triangles are congruent, and hence that is the by the ASA test of the congruence. Therefore, the segment AB is a congruent to segment AC, and that's why the triangle ABC is a isosceles triangle. Now the next, this is again very important. In figure, the segment PR is a congruent to segment PQ. Show that the PS is a greater than PQ. PS is a greater than PQ. That's why we want to consider the whole triangle, big triangle. That's a PQS. Now see this here. That a PQ is a congruent to PR. No problem. That is a side opposite to, and these angles, that is a opposite angles, that is which are, that is the angle PQR is a congruent to angle PRQ. Okay. Therefore, the PRQ is a congruent to PQR. Isosceles triangle theorem. And now consider that is the angle PRQ. This angle PRQ is the exterior angle for of the triangle PRS. PRS जर आपण हा ट्रायंगल कन्सिडर केला, त्यातला हा PRQ काय होणार, तो एक्सटेरियर, आणि याचं मेजर या एस पेक्षा कसं असणार आहे, तर जास्त असणार. ओके, दॅट इज मेजर ऑफ अँगल PRQ is a greater than PSR. That is the property of exterior angle of the triangle. Now what will happen? That is the measure of angle as the measure of angle. ही दोन्ही मात्र कसे आहेत? PRQ and measure of angle PQR. These two angles are same. Therefore, the measure of angle PQS is greater than measure of angle PSQ, and this we want to prove. And तेच आपल्याला prove करायचं. That is the measure of angle PQS. Measure of angle PQS is greater than measure of angle PSQ. Measure of angle PSQ. म्हणजे काय की या दोघांचं माप किती, तर XX आहे. Measure of these two angles are XX. Suppose that as this is isosceles triangle. What about here? Measure of angle this PSR is Y. But this measure of this X is exterior angle. Its a measure is greater than Y, and this is also X. It means that the measure of angle PQS is greater than measure of angle PSQ, and hence that is a segment. That is now the side opposite to angle PQS is a PS, and side opposite to angle PSQ is a PQ, and that's why PS is a segment PS is a greater than segment PQ. That is a side opposite to greater angle is a greater. And then now next question. In figure, in triangle ABC, in triangle ABC, AD is a perpendicular to AD, segment AD and the segment B are the altitudes and the AE is equals to BD. Then prove that AD is a congruent to B. Now see this in this figure. In triangle ABC, AD is a perpendicular to BC, B is a perpendicular to AC, and what he say? This AE, length of AE and the length of B both are the equal. What we want to prove that is AD is a congruent to B. Now we'll consider the two triangles. We'll consider the two triangles. Which are the two triangles? Suppose that triangle I consider like this. That is a triangle AEB and the triangle BDA. In these two triangles, segment, one segment, that is a segment AB, that is a common, and which is the hypotenuse for these two triangles. These are two right angle triangles, and one more sides, that is A is a congruent to BD. That is, in these two right angle triangles, the hypotenuse AB, which is the common, is a congruent, and one more the sides, that is A is a congruent to BD, which is given. Therefore, these two triangles are congruent by side hypotenuse test. And that's why AD is a congruent to BE and the corresponding sides of congruent triangles. Now see this here. In triangle ABD and the triangle BEA, that is the measure of angle ADB is equals to measure of angle BEA, each 90, which is given. And the hypotenuse AB is a congruent to hypotenuse BA, which is common sides. And the side DB is a congruent to side A, again that is a given. Therefore, these two triangles, that is the triangle ADB is a congruent to triangle BEA by the hypotenuse side test of the congruence. Therefore, segment AD is a congruent to segment B, and in this way, that is we have proved that AD is a congruent to B. In this way, we have completed the practice set 3.4. Now we'll see in the next video. Till then, goodbye.